Hello everyone and welcome to a new video. Today I would like to bring more excitement to what a few of you would call unexciting world of software testing. We will talk about testing applications that interacts with Neo4j instances or external systems in general. So what's the problem when it comes to integration testing? First of all, we need to make clear that we all understand for this video the same. Integration tests in this video are a synonym of tests that get executed against some external system and have some interaction with it. For example, a database. The moment you want to validate that your code is really doing what it should do in the real world, you need to have a system you want to interact with running. So the database has to get started before our tests execute. There are plenty of ways to achieve this. For example, running the database in embedded mode, if this is an option is available. Running the database in server mode on your local machine, or running the database on a dedicated machine. So you have a remote server you connect to. If you ask me, mocking the test is not a valid option to say this is an integration test. Also, there might be some variants of the three options I've mentioned, like running the local server in Docker, but we will talk about this later. All of those options have some costs and some downsides, if you ask me. Let's start with the embedded mode. If your database vendor offers an embedded instance, it might look like a good fit to have portable builds, meaning you bundle the embedded instance as a dependency with your application, and no matter where you execute the tests, locally or be it on your CI server, it will always use this instance. So a fresh start, for example, can have pre-populated data that is needed for your tests, and you are most of the time safe against modifications from the outside. But this comes with some costs. Before we talk about the pitfalls you might experience during runtime, we need to get the embedded instance running first. Here there can be first problems. In the Java world, you typically would have some dependencies depending on the project structure, multiple dependency definitions, but at the moment the embedded version of your database demands other versions as the dependency versions you have already defined in your application, you have to choose. There is barely any database that has everything shaded inside. In the broader picture of this issue, you might also experience that the database requires the JVM version, a specific JVM version it wants to run with, be it higher or lower. Even if it's not a problem for you, you have to make compromises in the end, which versions you want to bundle your application later on. Assuming the previous problems do not occur in your project setup and you have started the instance, some issues might still wait for you. First of all, we have the non-existing network. What seems to be a good candidate to get rid of for your test might also be, on the other hand, trigger unexpected behavior. I don't want to get into network connection in general, like retries and not available machines, but more about the generated data. Compared to an external system, this data lives within the same JVM then as your application. And it's much harder to determine if the data you are querying already left the database or is still in the making. Also, you have to dig deep into the memory analyzer to figure out if the memory consumption that might be a problem happens within your business code or in the database. Another problem I would like to mention here are the limited options for analyzing your test runs after failure. Since the database will get started and shut down with the running tests, it is hard to verify what the data in the database looks like after the tests without using some tweaks to keep the instance running or to save the data somewhere or the state of the database. To separate your application with your tests from the database, you might consider running an instance of the server and the system you want to connect with on your local machine. In a sudden, you will get rid of all the problems the embedded instance brings with it regarding versions. But now you have to take care about the test environment. How should others on the team set up the database if you're not using the default configuration? And of course, you need to have some kind of setup script in your CI server to spin up the database or to tear it down. This brings another vector of complexity to the project. Running those integration tests will always require you to set up a proper or more powerful CI infrastructure. And you need to take care that all local and CI instances running the same version of the database. There might be differences between some minor versions, but similar. So a lot of those setup and infrastructure questions can be solved using Docker, for example. But we will talk about this later. First, let's talk about the third option, running the database on a dedicated external machine for everyone. This omits the configuration of the test instance. It really does not omit it, but you can now focus on one machine to have the proper setup, proper configuration, and it might even run with better hardware. But this can become a debugging nightmare. In the case you are just working alone on the project, your CI will get your biggest enemy in this case. Using one instance means that you definitely will share data with others. Even for empty databases, you might accidentally share the same tables, created nodes or documents, whatever your database type is. If you hit the sweet spot of you and, for example, your CI running the same test, or a related test to the objects, nodes, etc. you want to work with, you will encounter test issues without any obvious reason. Running the tests again will be successful, and the only mood you're left with is uncertainty. The data is already gone because of other tests that ran too, and you cannot be 100% sure that another person on your team or your CI server was causing the problem. I mention this because it's sometimes not this obvious that this will happen when you access this instance, and I know how this feels. Of course, if something of this works good for you, I won't try to convince you. But overall, the previous parts were quite negative. Now finally something to cheer you up. I already mentioned Docker. Docker in the context of local test instances, and I think that besides other advantages and disadvantages Docker might have, it's a good fit for running external systems like databases for testing. First of all, you get a clean instance of your database with every start. From there on, you can put in a matching configuration for your environment, initial data, and something else if needed. And if you don't want to manually start this up, there's already a Java API. One problem you might encounter when using Docker programmatically in your test setup is the detection of the readiness of your system. Even if the container started up perfectly fine, this does not mean that the database is there and ready for interaction. Also, other interactions feel more like having the powerful command line API of Docker in an API, in a Java API, but with a more clear path how to use it. This brings me finally to today's topic, test containers. First of all, you can think of test containers like some kind of wrapper around the Docker Java API. There is more, but for now it should give you a right impression. What makes it so powerful is, for example, the awareness of not only the image you want to work with, but gives you a hooks to describe readiness for your system. This means it explicitly says it's ready when you say it's ready. For convenience reasons, Testcontainers also provides seamless integrations with JUnit. You can inject containers into your test suite and work seamlessly with them. It is possible to copy data into the container before you run the test or create complete network setups with several systems that need to be ready before you test. And last but not least, there are already a ton of pre-configured, ready-to-use modules available in the test container ecosystem. You don't have to figure out how to start a Postgres instance or a Kafka server. It's ready. It's there for you to use. To see this in action, we will now have a look how you can use test containers in general and Testcontainers Neo4j in special. This small project is based on Spring Boot and uses Spring Data Neo4j to persist a few nodes, or to work with nodes. To keep the business logic simple, we will have an entity type material that will get stored and retrieved from the database via a material repository. Now let's focus on how to get this tested. First of all, we need to get the latest version of test containers into our project. For this, we add the dependency of the JUnit support directly to our POM. In the first place, we will not use any JUnit related features, but this will come in handy in a minute. With this setup, we can now make use of test containers in our test case. As you can see, I have already prepared some simple test setup. The test code gets the repository and the Neo4j client injected, and is now just waiting for us to write some tests. So let's add one simple test first to this class. We want the repository to fetch all materials from the database. Let's run the test and see what will happen. It's pretty obvious that the test fails because there's no database. There's no database running to connect our application to. But the code infrastructure is working, and we can now focus on creating the environment before we jump into the specifics of Testcontainers Neo4j. We have already the basic test container functionality available. I will now add a generic container to the test and make it use the latest Neo4j 5 image. Also, we would need to define our credentials the database should initially be configured with. And also, we need to expose the internal bold port to be accessible from our application tests. After we define the container, we need to take care that it will get started before our tests. When we now start our tests, we can see that test containers will pull the image and start up an instance. Also, you will notice that the test is still failing. This is because we started the database but did not yet tell our test code about the right coordinates to connect to. To make this happen, I will add a dynamic property source to our test suite to make our Spring managed application aware of where the database can be reached. Don't worry, it will look nicer at the end. But for now, this should work as intended. Let's start the tests again and verify this. Perfect, a green check mark. To clean up the code right now a little bit, we can make use of the already mentioned Testcontainers JUnit extension. We already defined the dependency. To enable the extension, we add test containers to our test suite, and we will mark the container, the already defined container, with add container. This helps us to not bother with the lifecycle. Again, verifying that our test runs, and done. Next on our list is the setup of Testcontainers Neo4j. First of all, we now add the dependency to our POM. With this, we can now use the Neo4j container instead of the generic container. Replacing the class will make us benefit from a more Neo4j specific configuration. We can get rid of the generic port mapping and environment variable, and we add the credentials. With this container setup, we can now head over to our dynamic property source again, replace the string concatenation of our coordinates with the informations the container gives us. Also, we can access the admin password here. So in the future, if you would make any modifications to this setup, it will get kept in change. Let's see if this breaks anything. Perfect. It's now running. It's a simple but portable test. If anyone else on the team or CI server wants to execute this test and has Docker enabled, it will run completely independent from outer influences. As you have seen before, I also put in Spring Data Neo4j's Neo4j client. There are use cases when people don't want to have object mapping, but want to execute a more complex query to analyze the data. For example, by using Graph Data Science or the Epoch plugin. Let's write some test code for this. Just query the version of the plugin installed. Running this will show us that it's obviously failing. Epoch, like other plugins of the Neo4j Labs project, are plugins that need to get defined as environment variables to get loaded into the container at startup. This is the Neo4j Docker container feature. To ease this situation, the Neo4j module of test containers has a built-in mechanism to define those plugins. The only thing I need to do right now is to extend our configuration and add the with Labs plugin. We choose Epoch here. Running this will now show us the test running green and everything is installed. But there's more in there to explore. For example, you can make use of the Enterprise Edition if you accept the terms and conditions. Also, it is possible to set the Neo4j server config in a more convenient way than just throwing in environment variables. With test containers, we developer have a not so new tool at our hand that allows us to create portable and reproducible tests within seconds. The integration for JUnit is superb because it does not require you to manage the lifecycle. Sure, if you want to do this, you can still do this if you have special needs. But it's optional and not mandatory. On the API level of test containers, there's even more to explore. For example, the experimental reuse function for containers. You might have already wondered how it impacts the performance if I run test containers from integration tests. With this, the container will only get started once and, like the option says, get reused in the other test runs. And so I can improve my performance even more. What I need to say about the tests themselves that we have seen here, they test more Spring Data Neo4j than your business logic. So your test should really focus on your business logic. But I think to make the point clear how test container works, it was good to just have the simple test about that executes some tests. In general, I think test containers is a great choice to improve your test suite. It's a powerful library that does not require you much to get started with. And if you ask me, it will stay here and get a standard. Thanks for watching this and see you next time. Bye.